Good day, everyone, and we meet yet again. So I just I know that you're preparing actually for the exams, so I just wanted to just drop this quick video just to show you how to tackle this question. Um, I got this question actually from one of the past exam questions, and I just thought I would take you through it just to show you how to tackle these sort of questions going forward. It's on projectile motion, so please, if you haven't subscribed, please welcome to the family. Just hit that subscribe button, and by the way, you can just drop a thumbs up if you like this lesson and many others that we are going to dish out. Okay, right. So I'm just going to narrate this question quickly just to show you how to navigate your way around them. Okay, so what we are given here is they tell us that they drop ball X rather, and at the same instant they throw ball B. Okay, right? So think about it. Same instant, they throw this one up and this one is dropped. Okay. And of course, as this one goes up, this one comes down. At a certain point, they are just going to meet there. Now, they say to you, calculate the time it takes for the balls to pass each other. Okay. So now I want to show you how are we going to answer this question very quickly, right? Now let's take ball X. What information do we know about ball X? So let's start with ball X, okay? Now, what I'm going to do is, let me just assume that from the moment that ball X left to where they meet, okay? Let's call that distance, whatever you want to call it. I'm going to call that distance P. All right. Let's call it P. In fact, let's call it D for distance. Okay. Right. So I'm going to call that distance D. All right. Now remember what I said to you on projectile motion. Okay, I said the most important thing is always to choose a positive direction. Okay, so what I'm going to do, let me choose direction downwards as positive, and it really doesn't matter. You could have chosen upwards. If the examiner doesn't dictate that to you, okay, you can choose either direction as positive, right? But I'm going to choose downwards as positive. Now, so from the moment that ball X is dropped up until it gets to where they meet, so this is where the two balls are going to meet with each other. So there's ball X, there's ball Y over there. Okay, we don't know how far it is above the ground. Okay, now let's try and fill in information for ball X. Let's start with ball X, all right? So I want you to understand this. I'm starting with ball X and I'm saying, okay, what do I know about ball X? Do I know what my initial velocity is? Okay. For ball X, well, they said to me it's dropped. So I know that initial velocity is going to be 0. Okay. So this is initial velocity from the moment it was dropped up until that distance there. I don't know what you want to call it. Okay. So, but we said that distance is D there. So initial velocity is 0. What is our final velocity? We don't know what would be the velocity of ball X, what the velocity of ball X would be at that point. But we do know gravitational acceleration, isn't it? Right? We've taken down as positive. Okay, so it means that this is going to be a positive 9.8. Remember that gravitational acceleration is always taken vertically downwards. So it's 9.8 meters per second squared. And we say that the time, okay, now for the sake of answering this question, let's call the time, let's say the time that it takes from there till there is going to be time t. Okay, right, so let's call it time t. Okay, right, and then what is the displacement in that case? Okay, we said our displacement, remember we said displacement is the straight line change in position from beginning to end point. So from beginning to that point there, we said it traveled the distance d. Okay, so as a result, let's call that positive d going downwards. We said it's positive. Why? Because we've chosen down as positive. Okay, Now, what I'm also going to do is I am going to now try to populate information for ball Y. Okay, right? Just stay with me as I do this. So I'm going to try and fill in information for ball Y. Obviously, you would do this quicker. It's just that I'm explaining in the process. I'm not just answering the question. Okay, right. Now let's go for ball Y. So do we know initial velocity for ball Y? Now think about it. Ball Y starts from the ground and it gets up to that point there, okay? And we're going to talk about that point in just a few. So what's the initial velocity? It's going to be 20 meters per second. However, remember that we've chosen down as positive. Where is ball Y thrown? It's thrown upwards, so that will be negative 20, right? Remember, it's going upwards. Right. Final velocity, well, I don't know what the final velocity will be when it gets to that point where they meet. So I will leave that as unknown. But what is my gravitational acceleration? Once again, ball B is going upwards. However, gravitational acceleration, remember, always pulls vertically downwards. And that's where many people actually get to lose it when it comes to projectile motion. Okay? Please keep in mind, gravitational acceleration always acts vertically downwards. As much as ball Y is going up, but gravity is pulling it down, and that's why it will slow down going upwards. So that's why we're going to say okay. So it means that gravitational acceleration is also positive 9.8 meters per second squared. Just a side note, ladies and gents, just remember that gravitational acceleration depends on the direction of choice. Had I chosen up as positive, in both instances, my gravitational acceleration would have been negative. Why? Because gravity always pulls down. Okay, and as a result, because up is positive, it means down would be negative, and so it will be negative for both instances. Okay, so I hope that makes sense, and that's where many people actually get to lose marks when it comes to projectile motion. Okay, right. So how long would it take for ball Y to get to that point? Now think about it. We said we threw these balls simultaneously, right? And what happens? There, as this one goes up, this one goes down. So the time that it took ball X to come down to this point, it would have taken the same time for ball Y to actually get to the same instance. So the time there would be common. All right, think about it. So we said time t, it takes t seconds for ball X to get to that point. So it means it takes Y the same time to get to that point. Now let's talk about this displacement over here for ball Y. Now they had given us that the building is 50 meters high. They threw ball X from the top of the building. They threw ball Y. They dropped rather ball X from the top of the building. They threw ball Y from the ground. Okay. Now, if you think about it, the total distance there is 50 meters, okay? Now, if I let these balls go, obviously we said this one drops d meters. Now, how long would be the distance here, right? So, if that's 50 and we move d meters, what's left here? Definitely it would be 50 minus d, isn't it? So it means that that distance there would be 50 minus d. If you want to check, 50 minus d plus d would give us that whole distance there, which is 50. Now, ladies and gents, I can bet you many people make this error. So I know the distance here is 50 minus d. However, we are talking about displacement, the displacement of ball Y, right? Now, we chose rather downwards to be positive. So what does it mean? Ball Y is going upwards. It is displaced upwards. So as a result, it means that it is displaced in the negative direction, right? Okay. So as a result, that displacement would be negative 50 minus d. I want you to please keep that in mind, and that's what will either make or break your answer for this particular question. Okay, so I hope that made sense. I'll say this again. Remember, ball X went down, so we said that distance there is d. However, its displacement is downwards, and that's why we kept that positive there. Okay, because we said down is positive. Ball Y goes moves 50 minus d meters. That's the distance, right? However, remember in projectile motion we talk about displacement. Okay, so in this case it is displaced upwards. So in this case it's displaced in the negative direction, and as a result that's going to be 50 minus d there, right? Okay, so now we want to find out. They said to us, and by the way, I think this was for 5 marks, okay, and the other question for 4 marks. And you'll see that actually we're more or less going to take the same approach to answer both questions. So let's start with the first one. They say calculate the time it takes for the balls to pass each other. So we want to know how long would it take for them to get to that point there. Now let's start with equation D, with ball X rather. So what do we know? So definitely we don't know final velocity. You agree with me, right? And in this case, we wanted to find out what this time t is. So I'm going to make sure that I pick an equation that does not have final velocity, VF, okay? All right? But I'm going to rather pick an equation in this case that definitely has time. So which is the only equation in equations of motion that does not have final velocity? I'm sure someone is looking into their table or their data sheet, and they can actually see that that would be the third equation, okay, the one that simply says delta y, okay, is vi delta t plus 1 over 2 a delta t squared. Now, so this is now for ball X. So we're still busy with ball X, right? Okay, now let's substitute all that we know for ball X. Let's substitute everything that we know. We know that delta y in this case, what's the displacement? We decided to call it d. Okay, what's our initial velocity? Our initial velocity is 0. Okay, so it makes this whole thing become 0 over there. Okay, and I'm going to just simply say, but that's half. What's our acceleration? We said that's gravitational acceleration. That's 9.8, of course. For those of you in South Africa, we are using this equation. There are some who still prefer the S is equals to ut plus half at squared. Okay, that's still okay. So that's half times 9.8 multiplied by, remember we said our time there, delta t, we just decided to call it t squared. Okay, right, now let's try and leave that equation in simplified form. So this is going to be d is equals to half times 9.8, that will be 4.9, okay, t squared. Now I'm going to leave this equation in that way. You can see we cannot solve further because we've got two equations, okay, and two variables and only one equation at the moment. So I'm going to leave that as equation 1, okay. Remember this was just for ball X. Now I'm going to go to ball Y and we try to do the same. Which equation are we going to use for ball Y? You'll see once again we don't have final velocity over there. Okay, so I'm going to avoid using an equation with final velocity. So it would basically be the same equation, right? So delta y, again, that's vi delta t. I should have just substituted, but hey, I've already done it. So so that's half a delta t squared. So let's substitute. What is my displacement? And you'll see why that it was so important to actually indicate that there. So my displacement, that's 50 minus d. Okay, so now let's substitute what is our initial velocity. That's minus 20. Okay, but you remember we took the same amount of time t there, right? Okay, so that's minus 20t plus, this is half times 9.8 again. Okay, some prefer to use 10, you can use it. Okay, but obviously for us in South Africa, we are confined, okay, to 9.8. Okay, so 9.8, and we know that our time is t squared over there. Okay, let's try and simplify that. So now I've got minus 50 plus d. Okay, so substitute, or rather multiplying that negative into the bracket, that's negative times 50. Okay, that's negative times negative, that's positive. Okay, so this would be minus 20t. Okay, and you'll see there once again you've got half times 9.8, which will give us 4.9 t squared. All right, and once again you've got two variables, d and t. So I'm going to call this equation 2. Okay, now let's try to solve. Okay, so what you can do is, you already had equation 1. Let's substitute equation 1 into equation 2. So that means I'm going to substitute, substitute, in fact, let's say substitute equation 1 into equation 2. So that means everything that has d in equation 2, I'm going to substitute 4.9 t squared. So I have minus 50, okay, plus, where I see d, I substitute that 4.9 t squared, okay, which is minus 20 t plus 4.9 t squared. I'm sure all the mathematicians are already screaming at the top of their lungs. I can see what's going to happen here. All right, so I've got 4.9 t squared here, 4.9 t squared there. Fortunately, I've avoided using a quadratic equation, so we can cancel on both sides. Okay, that minus that, those would simply cancel each other. So now what am I left with? I've got minus 20t, okay, which is equal to minus 50. And of course, you can see now, you can just divide both sides, minus 20 and minus 20 over there. And if you don't mind, I'm just going to give the answer over this side here. Okay, so that cancels that over there, and 5 over 2. So it means that they will meet at a time 2.5 seconds. Okay, so that's 2.5 seconds later. All right, I hope that makes sense. And now you'll see that it makes it very easy now to answer the next question. Okay, I hope that's been really helpful. So now it becomes easier to answer the next question. Okay, I'm just going to push this up a little bit so that you can see how I answer that. I'm just going to utilize the space over here. Okay, they say now calculate how high above the ground will ball X be at the instant the two balls just pass each other. So they want to know how far above the ground will ball X be, right? So in this case, I mean, we've just gotten the time where they meet. It's at 2.5 seconds, isn't it? Okay, so all that we simply do, we can substitute that time into any of the equations. Of course, equation 1 looks easier. So I'm going to say, all right, let's substitute, okay, for t is 2.5 seconds into equation 1. Okay, so I'm going to substitute that into equation 1, and I'm quite certain you can already see there d is equals to 4.9, okay, times 2.5 squared. Okay, all right, so I've substituted the t there for 2.5 squared. Let's see our calculator. So we've got 4.9 multiplied by 2.5 squared, and I get a value of 30.625, right? So that's 30.625 meters. I'm only going to make sure that I round off at the end. Okay, so remember, what did we just find here? We found the time, or rather the distance d, but they were not interested in distance d. They want to know how high above the ground, meaning from this point here. And remember, so it's 50 meters there, but we found out this distance is 30.625. So therefore, what will be the final answer? We'll simply say 50 minus that 30.625, okay, and we will get 19.375. So it means that the distance above the ground, okay, so the distance above the ground will simply be, okay, so that's 50. It's that 50 minus d over there. So that's 50 minus 30. Okay, sorry about that. 30.625. And at the end of the day, we get 19.375. We can round it off if you want to, and just say, usually they ask you to round it off to 2 decimal places. Okay, so I'm just going to say it's 19.38. Okay, so that's 19.38 meters. Okay, right. I hope that's been really helpful, ladies and gents. That is how you would tackle those questions. And by the way, I've also seen a question whereby they tell you that they throw ball Y and throw ball X 1 second later. All that you do in that question is exactly the same approach, but in terms of time, if ball Y was thrown first, right? And they dropped ball X 1 second later. So it means that if you say the time for ball Y would be T, the time for ball X would be actually T minus 1. Okay. So that would be the fundamental difference. Okay. So obviously, I'm afraid to just do the questions for you. But obviously, I want you to attempt as many as you possibly can on your own. I've given you the approach, and I hope that is helpful. And shout out to all those who've been sending questions, by the way, and I'll try to always tackle those questions with you. And I hope that you're working hard, ladies and gents, preparing for those exams. Otherwise, I'll see you guys next time. So it's bye-bye from me for now. Sharp, sharp.